Well, hi, everybody. We've made it to the last chapter of the year. We're talking about climate and climate change for chapter 20. So these are the chapter 20 notes. These are the last notes you're going to take. We'll basically spend this week covering some of the basics of chapter 20. And then the following week, which is kind of the last full week of e-learning, you guys will be spending that time preparing another Google Slides presentation, kind of similar to what we did uh, for the astronomy presentation, although without a paper. There won't really be a writing component to it. So we'll talk about that next week. Don't worry about that. Again, you're expected to kind of follow along here. You can pause if you need to, but you're expected to take notes and type up the parts that I've circled, put them in a Google Doc, and then submit them in Canvas when you're done. So we're talking about climate. Climate involves how all of the atmospheric processes, all the processes that involve water, rocks, life, and even ice and snow all fit together to make our weather patterns and our weather what they are over a longer period of time. So we've talked about many aspects of weather already, but we're really talking about how all those aspects fit together to make uh, the average weather patterns what they are in certain places. So every place on Earth has a distinctive climate. And usually when we talk about climate, we talk about things like average temperature in a certain month or a certain year, or average amounts of snowfall or rainfall and precipitation. We have a way to classify climates. There's actually several different ways. The type we're going to talk about here is the Köppen classification of climates. We're going to leave out a lot of the details here. You'll be answering a few questions about this on the reading quiz eventually. But we're not going to do too much writing here. I just want you to summarize the 5 main types of climates that the Köppen climate classification system has. They are A, so you'll type these here. A, humid tropical. B, dry. C, humid mid-latitude with mild winters. D, humid mid-latitude with severe winters. And E, polar. So we can break the world into all these different climate classification systems here. We're just going to talk briefly about each one. Humid tropical climates are the ones where it's hot all year and it rains a lot all year. Typically, every day, practically, you get rain, and the average temperature is always very warm. So parts of southern Florida might qualify as humid tropical. There's also tropical climates that are classified as wet and dry, where they get all of their rain in one part of the year and then it doesn't rain at all for 6 months. Some temperature precipitation graphs from a few cities that have this. Next, we have dry climates. This is where evaporation exceeds precipitation. Obviously, these are going to be most of the world's deserts. There's differences between arid and semi-arid. Really, arid is kind of the severe desert. Semi-arid is less severe, where maybe a slight amount of rainfall is enough for some grasses, maybe a few very small trees to grow, but too dry for forests or very much vegetation. Here's some examples there. What causes these dry climates here? Just a couple reasons why. Um, where there's always high pressure systems, as you learned about in previous chapters, there's always sinking air. There won't be a lot of cloud formation and precipitation. So that's one reason. Another reason could be a rain shadow. When when air passes over a mountain, it tends to be dried out. It releases its moisture on one side of the mountain, and then by the time that air gets to the other side, it's dry. So there's no humidity left in it. You can really see on a map that this is the humid tropical area right here along the equator, where it rains almost every day. And on either side, we have 2 of the world's great deserts. So sometimes just taking a look at a satellite picture from space, it's pretty easy to identify different climates. Guess I'm going the wrong way there. Got to go back to the right direction here. We're going to move on to uh, mid-latitude climates, which have mild winters. We're right on the borderline between mild winter and severe winter. Really, it just means that there is a even colder temperature in the winter. One of the unique things about mid-latitude climates is they have a very big difference between the highest and lowest, or the hottest and coldest months of the year. You know that we can have temperature ranges of about 100 degrees in the sense that it can achieve 95 or 100 degrees on the hottest day, but it can also be below zero. That's unique for our climate type. And finally, polar climates, where the average temperature is always below freezing, so any snow that falls never melts. So you didn't have to do too much writing there. Here's where most of the writing comes in for these notes. It's going to be on not the climate types, but the human impact on global climate, which is also referred to as climate change. This is also the topic of your research project that you will be doing next week. So, what is global warming? Some people get global warming and the greenhouse effect confused with each other. The greenhouse effect is necessary, it's needed. It's the trapping of heat by carbon dioxide and other greenhouse gases from escaping back into space. But because humans have added extra greenhouse gases to the atmosphere by burning things, that extra CO2 is trapping more heat, and therefore the planet is warming as time goes on. So as I said, there, burning fossil fuels have added great quantities of carbon dioxide to the atmosphere, and this is the reason why the planet is warming up. Let's take a look at this. We actually can drill holes in the ice in Antarctica and Greenland, and we can find trapped gas bubbles, and we can measure how much carbon dioxide is in the atmosphere. You can see that it goes up and down in kind of a cyclical pattern. This has to do with the some wobbles in Earth's orbit and Earth's rotation. Uh, but since about the year 1850, it's been skyrocketing, and right now it's twice as high as the amount of CO2 in the atmosphere is twice as high as at any point in the last 500,000 years or more. More CO2 means more heat is trapped in the Earth's atmosphere, and this is warming the planet. This is called global warming. I kind of just covered this. This is the response to that. Because of that extra CO2, Earth is warming, and we're going to continue to warm. It's predicted that we'll warm by 5 to 8 degrees Fahrenheit by the year 2100. There's a few other gases also that have a role here. The main one we'll be studying about, though, is carbon dioxide. Although if you're interested in studying some of these other gases and how they relate to climate change, you can certainly use those as topics. When climatologists and meteorologists study climate change, they try to figure out what's going to happen as a result of of our warming planet. There are positive feedback and negative feedback mechanisms. Positive feedback mechanisms make the warming worse. Negative feedback tend to sort of cancel it out. Quick example of a positive feedback would be the melting ice caps. As the Arctic Ocean melts more and more in the summer, instead of sunlight coming in and reflecting back off this white surface, more and more is being absorbed by the darker water, the open water, and that's making global warming worse. Uh, an example of a negative feedback mechanism might be more warmer temperatures mean more evaporation, more clouds. Clouds tend to keep the planet cooler. That would be a negative feedback response. All in all, though, we do see that positive feedback mechanisms are winning. So that's it uh, for feedback mechanisms. We want to take a look at some models, some theoretical models that take data and try to predict what's going to happen as a result of climate change in the future. We can see that looking at this past graph here, we would be able to predict that the temperature might be rising, but also tend to go back down in the future. So the natural trend that we would expect is gradual cooling. In fact, though, what we have been seeing is this very rapid warming of the temperature at the same time that those CO2 levels have increased. So the computer models and simulations that we've run seem to show that this is what we're experiencing and this is what's happening, and it will continue happening. What can happen because of global warming? Well, some of these are obvious and some maybe not. We've seen changes in where water is in the world. Some places are getting more rain, more precipitation because warmer temperatures cause more evaporation, more clouds, and more rain. But it also causes more evaporation, so some places are drier. We continue to see and will continue to, we have seen and will continue to see a rise in sea levels. And we've seen changing weather patterns. your parents or grandparents have noticed that the weather isn't quite the same as it used to be, they're not wrong. So we can't just call one cold day in July or one hot day in January climate change. But when we start talking about longer term averages, we can certainly talk about the fact that the weather averages and patterns are not what they once have been. So meteorologists have noticed changes in weather patterns. Here's a graph of sea level rise. It was rising slower in the past, and if we focus on from 1993 to 2012, we can see that it's rising almost 3 times as fast since 1993. So it seems as though the planet's warming and the melting of the glaciers and ice caps has been accelerating. Well, that's it for the notes. Again, go ahead and copy those into a Google Doc and submit those in Canvas. That's it for now. Good luck and have a good day.